Hello and welcome everyone. In this video, we will cover some methods that are useful for doing statistical analysis. Most of the series methods that perform a calculation ignore nan or missing values. Some also provide an optional parameter, skip na, to change the behavior. Here we compute the sum of the values in the series. We can also compute the mean and median values, and we can compute the percentiles as well. So if we don't specify any parameter, this will compute the 50th percentile or the median value. We can also specify these percentile values. Here we are computing 10th and 90th percentile. We can also use the describe method to compute the summary statistics. If we don't specify any percentile in the describe method, we get the 25th percentile, 50th percentile, and 75th percentile. We can specify the percentile values as well. Here we get information about 10th percentile, 30th percentile, and 80th percentile, along with the 50th percentile or the median value. We can compute the minimum and maximum values using min and max methods. We can also get the indices corresponding to minimum and maximum values. To find the spread of the values, we could use .var method or the standard deviation method. Here we see that variance is just the square of the standard deviation values. One of the data distribution that we most commonly use is the normal distribution, and in this distribution 99.7% of the values will be within 3 standard deviation. And if we look at this table, we can see that 68% of the values will be within 1 standard deviation, 95% of the values will be within 2 standard deviations, and as I said before, 99.7% of the values will be within 3 standard deviation. Another important statistical property is the skewness, which measures how the tails behave. So a negative skew indicates left tail is longer, whereas positive skew indicates the right tail is longer. To demonstrate that, we generate these two series. Since we will also require some plotting, so we import matplotlib pyplot. Then we generate the histograms using the hist method on these two series and plot those. And here we can see that the skewness is negative. It means the left tail is longer, and here the skewness is positive. The right tail is longer. Another important statistical property is the kurtosis, which describes how narrow the peak of distribution is. A large kurtosis means narrow peak, whereas smaller kurtosis indicates broader peak. And it returns nan for data less than 4 values. Covariance is a measure of how two variables change together. When both increase or decrease, it leads to a positive covariance. So here we have generated 4 series. Here we are computing the covariance between series 1 and 2, and here we are computing the covariance between series 1 and 3. In series 1 we go from 0 to 10, in series 2 we increase from 10 to 20, and then in series 3 we go from 10 to 0. So we should see a positive, negative, and positive response here. And that's what we see here. So when the covariance is normalized, and it is done by dividing by the standard deviation of both series, it is called correlation coefficients. And it can also be computed using .core method. So let's run these, and we can confirm that both methods produce the same results. So we do this for the series 1 and 3, and we get the same results. That is a negative value. We could also do autocorrelation, and we can also compute the discrete differences between samples. Finally, we can compute the cumulative summation, product, and cumulative minimum values. So this was a brief overview of the statistical methods for series in Pandas, and we use these frequently in our data analysis. So now we stop here and we will continue from here in the next video. Thanks for watching.